Hi everyone, this is Fahad Mirza and I welcome you to the channel. In a very exciting news, MiniCPM-o 2.6 has been released. This is an 8 billion size parameter model which has beaten GPT-4o on various benchmarks, and in various other top benchmarks it has leveled with this GPT-4o model when it comes to multimodalities. It matches GPT-4o 2024-05 in vision, audio, and multimodal live streaming. It has got end-to-end real-time bilingual audio conversion, voice cloning, and emotion control. Its OCR and video understanding is also extremely optimal. We are going to install it locally and then we will see how it works on all of these modalities. If you look at its architecture, that is quite interesting. This is a latest series of end-side multimodal LLMs which has been upgraded from MiniCPM-v, which we already have covered on the channel. This new model can take image, video, text and audio as input, and it provides high quality text and speech outputs in an end-to-end fashion. This new capable model has got 8 billion parameters, and as I said, its performance has beaten even the top models out there. It supports bilingual real-time speech conversation with configurable voices, and it also allows for fun capabilities such as emotion, speed, style control, end-to-end voice cloning, role play, and it also advances MiniCPM 2.6 visual capabilities. Also, its architecture warrants something really cool, because if you look at this diagram, there are different modality encoder decoders which are connected and trained in an end-to-end fashion to fully exploit rich multimodal knowledge. They have also changed the offline modality encoder decoder into an online one for streaming. They have devised a time division multiplexing or TDM mechanism for Omni modality streaming processing in the LLM backbone. It divides parallel Omni modality streams into sequential info within small periodic time slices. So that was a quick intro of this model. Let's try to get it installed and then we will see how it works. Let me also give a huge shout out to our good friends at Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs. This is my Ubuntu system and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM courtesy Mast Compute. Let me create my Conda environment and make sure that you are using Python 3.10 because that is what it has been tested with. So my Conda environment is all good. Next, we need to git clone the repo of MiniCPM, and they also have very graciously shared and open sourced it, which is quite good. Let's wait for it. It is slightly larger repo, and that is done. Next up, we need to install all the requirements, and you can see that the requirement file is specifically for O2.6, and that is going to take a couple of minutes. And now let me launch my Jupyter notebook. Let's first download the model. And if you look here, we are importing the libraries, then we are getting the model, this MiniCPM-o 2.6 with this tokenizer. And this is slightly a newer thing. If you just want to load vision model or audio model, you can just set it to true and you can set the rest of them to the false. You also have to you have the option of doing the text to speech one just out of it. So that is what bit unique about this model. And then you can see that we are also initializing it towards the end. So let me run it. And the model is being downloaded, as you can see here. Let me scroll down. There are 4 shards of it. So it should be good on this GPU. Let's wait for it. And the model is downloaded. As you can see here, all the shards are there, and then it has also initialized the TTS. Okay, let's do the inference. As I said earlier, there are multiple functionalities of this model. You can talk with your images, you can talk with your videos, and you can also do multi-image and all that stuff. You can also do streaming. So let's see how we can talk to our video. Or if so what I'm going to do here, I'm going to give it the path of the video and then I will ask it to describe it. So first up, I'm just importing some of the libraries we installed earlier. They also have provided this encode video function in their Hugging Face model card, which I will drop the link in video's description. And this is where I'm giving it the video path from my local system, and I am asking it to describe the video. Now, one thing is that if you have a low GPU and you are getting out of memory error here, you can try reducing this number, max num frame, maybe go with 32 if you are getting memory errors, and just put it 1 here instead of 2. So before I run this, let me also show you the video. So this is a video which I'm going to test with it, just a sample video here. Let me play it. So this is just a random video which I made few months back, around just an intro and stuff. So this is what I'm going to run. Okay, so let me minimize it and let me run this code to see what it prints. And there you go, it has given us a description of the video, as you can see. So the number of frames are 22, and it is saying the video features a person seated in a room with a white wall behind them. So if you go there, there is a slightly whitish wall, that's correct. The individual is wearing a dark jacket with a hood. In front of the person there is a black object that resembles a microphone or a similar device. And then it is talking about keyboard, mouse in the background, very wooden blinds, very nice. Throughout the video, the scene remains static with no significant changes in the environment. That's very cool, really good stuff. Let me quickly show you the VRAM consumption too, because at the moment the model is loaded onto our GPU. So it is consuming around 27 gig of VRAM, which is not bad for a video model, which also does the TTS and audio, vision, all that stuff. Really good. Okay, so that is nice. Okay, next up, let me also run this with another video. So this is just another video which I created as part of other video with AI. So I'm just going to ask it about to describe this video. So let's run it. So this is the whole video. Let me run it, and I will let it run in real time so that you know the speed of the inference. There you go. Very quick. It says the video features a fluffy cat with a mix of gray, black and white fur. That is correct. Sitting on a rock with picturesque mountainous landscape. Throughout the video, the cat maintains a curious and alert expression. That is correct. So if you look at the expression of cat, they are really curious and alert. You see, it's very alert. Very fine inference, I would say. Really cool stuff. And now let me show you how it does the TTS. So I'm just importing the libraries, and there is a prompt. You can set it as you like. I am loading an audio file from the local system, and then we are doing the inference with it by passing it some of the hyperparameters. The output file, if you like, you can also store it here. So let me run it. Let's go here. Let's wait for it. So it says that it has done this transcription, which is what is happiness, and that is what exactly is in the audio. Let me quickly actually play the audio for you too. Let me take you there. So this is the audio. What is happiness? So you can see that it has perfectly transcribed it, and then it has also given us all the other parameters and configuration too. Let me try it out with another audio file. Let me play this audio file for you.
Then, leaving the corpse within the house, they go themselves to and fro about the city and beat themselves, with their garments bound up by a girdle.
Yep, that's good stuff. Let's go back, and you see that it has done a wonderful transcription here with all the parameters. So really good stuff, not only in terms of video understanding, but also in terms of TTS. And finally, let's check it out, its OCR capability. So I'm just going to give it this image from my local system with some of the English characters, alphanumeric, some other European languages. And I am asking it to extract the text from the image. So let's run it. Let's wait for it to come back with the response. Shouldn't take too long. There you go. So it says that this is the OCR. I'll just display it in parallel so you can compare. So as far as I can see in a quick glance, it looks really good to me. Even this rapidity, it has done well. So there is one E missing here, I would say. But other than that, looks quite good. Yep, I think not bad at all for this model. Really good. Okay, let's see if it can do OCR in other languages such as Arabic maybe. So this is just from an Arabic newspaper. So let's see what it does here. Okay, so I'm not sure if it has done well here. Doesn't look like it has done some Arabic, but with some telecom, I have no idea. I don't think so. It is multilingual, it seems, at least not in Arabic as far as I can see from this OCR. But anyway, English OCR seems quite good. TTS is good. Video understanding is also fine. I will drop the link to it in video's description. Towards the end, let me also introduce you to the sponsors of the video, who are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in video's description. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.